Welcome to Inquisitive Kids. My name is Karen, and today we will be going over the properties of fractional expressions. As you may remember from the last video, we learned all about the definition of fractional expressions and its connections with whole expressions and fractions. Now we're going to continue our connections with our past areas of study as we look at its different properties. Now, these properties of fractional expressions are especially important because this will help us learn how to simplify fractional expressions as well as how to conduct operations with them. As you can see, we will be doing with multiplication, division, addition, and subtraction. Learning goals. Understand and master the basic properties of fractional expressions. Use the basic properties of fractional expressions to reduce and generalize fractional expressions. Here's our introduction. If 3 apples are shared evenly between 6 students, how much apple does each student get? Well, here is our solution. 3/6, which is 3 divided by 6, we can first reduce it into 1/2. So this would be our answer. Each student will get 1/2 of an apple. Now let me ask you another question. Is 2/5 and -4 over -10 equivalent fractions? What is the basis for these two fractions to be equal? Well, the basis for these two fractions to be equivalent is that when the numerator and denominator of a fraction is multiplied or divided by a number not equal to 0, at the same time, the value of the fraction remains unchanged. This is the properties of fractions. As you can see in this question, we are using fractions, and these two numbers are fractions as well. Now, how will this lead us to the basic properties of fractional expressions? Are the following equations true? Why or why not? Here are the basic properties of fractions. When the numerator and denominator of a fraction is multiplied or divided by a non-zero number, the value of the fraction doesn't change. Therefore, for any given fraction a over b is equal to a times c over b times c. A over b is equal to a divided by c over b divided by c when c is not equal to 0. Do you believe that fractional expressions a over 2a and 1/2 and n over m and n squared over mn are equal? A, m, and n all don't equal 0. So now we're taking the basic properties of fractions and applying them to fractional expressions. Are these true? And if not, explain. Going back to the properties of fractions, can you think of the properties of fractional expressions? So what do you think the properties of fractional expressions are? Now, remember, relate back to the properties of fractions. Here are the basic properties of fractional expressions. When the numerator and denominator of a fraction are multiplied or divided by the same whole expression not equal to 0, the value of the fractional expression remains unchanged. The above properties can be expressed as a over b is equal to a times c over b times c. A over b is also equal to a divided by c over b divided by c when c is not equal to 0. Remember, this is very, very important. If c did equal 0, then this would not exist. So you must emphasize this point right here. C does not equal 0. And in this equation, a, b, and c are all whole expressions. So let's do example 1. Fill in the following blanks. Pause the video and solve on your own. How we got from this side of the equation to this side? Well, we divided it x, which means that we have to do the same to the top, or to the numerator. So x cubed divided by x would be x squared. Now for this one, how did we get from this first numerator to the second numerator? Well, we divided 3x. So doing the same to the bottom, we'll have 2x. And we have to emphasize that x is not equal to 0. Now for the second one, how did we get from the first denominator to the second denominator? Well, after we multiply both the top and bottom by a, we'll get a. And what about this next one? A squared to a squared b, u times b. So doing the same to the numerator, you will get 2ab minus b squared. And also this top should be a. So think about how in number 1, why is x not equal to 0 not shown, although in number 2, b is not equal to 0 is shown. Think about that. Think, what should we pay attention to when applying the basic properties of fractional expressions? Well, first, we have to pay attention to the keyword both. Both the numerator and denominator are multiplied or divided. Second, we have to pay attention to the keyword same. The same number is being multiplied or divided. And finally, we have to pay attention to doesn't equal 0. When we're dividing the numerator and denominator of a fractional expression, by a number, that number cannot equal 0, or else the value of the fraction will not exist. Here's example 2. Without changing the value of the expressions, simplify the coefficients of the numerator and denominator into integers. Now pause the video and use the basic properties of fractional expressions to solve. Here is our solution. Let's do the first one. Since we want to turn the coefficients into integers, we can see that the lowest place value that these coefficients in the first question get to is the hundredths place. So we can multiply both the numerator and denominator by 100. That way we'll get x minus 500 over 30x plus 4. Now for the second one. Since we see that both the coefficients of a here have a denominator of 10 since it's in the tenths place, and that the denominators of b, 3 and 5, have a least common multiple of 15, we want to multiply the numerator and denominator by a number that is a multiple of 15 and a multiple of 10, which would be 30. So after multiplying, we have 18a minus 50b over 21a minus 12b. Practice. Without changing the value of the expressions, simplify the following so that none of the denominators contain the negative sign. Pause the video and solve. Well, for the first one, we can simplify it into negative 2x over 5y. All we have to do is move that negative sign down. For the second one, since we know that two negatives make a positive, we can just turn it into 3a over 7b. And for the third one, it's the same as 10m over 3n. Now we are on our second chapter, reducing fractional expressions. How would you fill in the blanks here? Relating back to reducing fractions, can you figure out how to reduce fractional expressions? Reduce just means to simplify. How can you make fractional expressions into its simplest form? Well, similar to reducing fractions, the key is to find, here we are going to change it into greatest common factor, GCF, greatest common factor of the numerator and denominator of the fractional expression. So in the top here, since the greatest common factor is x, we're going to take it into x plus y over x. And on the bottom here, since the greatest common factor is x, we're going to turn it into y over x minus 2. So here is the definition of reducing fractional expressions. The removal of the common factors of the numerator and denominator of a fractional expression is called the reduction of the fractional expression. Removing common factors is something that we've learned using the distributive property in elementary school, and something that we just reviewed with factoring polynomials in our last chapter. And if it is in the form of a polynomial, how can you find the common factors? Well, you're going to have to factorize. Either remove common factors or use a formula to find its common factors. This is where factoring polynomials comes in, because if it's in a fractional expression, you need to be able to simplify that fractional expression. Let's do some discussing. When simplifying the fractional expression 5xy over 20x squared y, Kaylee and Karen had the following steps. This is Kaylee's solution and this is Karen's solution. So the question is, what do you have to say about each of their solutions? Now pause the video and compare the two, and then determine which one would be the correct answer. Neither of Kaylee or Karen is wrong, but their difference is that they removed different common factors. Kaylee only removed the y, while Karen removed the entire 5xy. Generally, the reduction should be thorough, so that there is no more common factor left in the numerator and denominator. In Kaylee's answer here, there is still more common factors. You can still factor out a 5 and factor out an x. So whenever you are simplifying fractional expressions, just like when you're simplifying fractions, you want to simplify it to its simplest form. Knowledge key point. Simplest fractional expressions. What does that mean? A simplest fractional expression is a fractional expression with no common factor left in the numerator and denominator, and that is called the simplest fractional expression. Notice, to judge whether a fractional expression is in simplest form, it must be judged strictly according to this definition. When the numerator or denominator is a polynomial, the numerator and denominator must be factorized first. So, if the top and bottom is not just a monomial, and instead a polynomial, you have to make sure you factor it first so that you see its different factors, and then that will make finding its common factor easier. Here is example 3. Reduce this fractional expression. And here we are already telling you that its common factor is 5abc. So all you have to do is use the common factor method that we learned from the last chapter. Here's our analysis. To reduce this fraction, we must first find the common factor of the numerator and denominator. Well, it's already given to us, 5abc. Here's how we can identify common factors. First, remove the GCF, greatest common factor, of the coefficients. And then we remove the same variables with the lowest index. So our solution would be, after removing 5abc, we have negative 5ac squared over 3b. Now here is our second fractional expression. Use the steps from the last slide to first identify the common factor and then remove the common factors to simplify. When simplifying, if the numerator and denominator are polynomials, it must be first factored. Do you remember the 3 different ways to factor polynomials from our last chapter? If not, you can have some more review because I will be linking its link in the description down below. In this question, we are using formulas. For example, the top can be split into x minus 3 times x plus 3, since it's using the square difference formula. And at the bottom, we have the perfect square formula, x plus 3 squared. After taking out the common factor x plus 3, we have x minus 3 over x plus 3. Here's some more practice. Simplify this first fractional expression right here. The common factor is already given. After removing the common factor of AB, you should have AC. Knowledge key point. Steps of reducing fractional expressions. 1. If both the numerator and denominator are monomials, the GCF of the coefficients and the lowest power of the same variable are removed. But if the numerator and denominator contain polynomials, first factorize the polynomials and then reduce all common factors of the numerator and denominator. So, simplifying a fraction doesn't change its value. The key to simplification is identifying the common factor between the numerator and denominator. And finally, simplification is performed on the entire numerator and denominator. For example, if you have a polynomial, it's performed on everything. Say you're removing factors. You have to multiply to every single term, not just one. Class summary. Today we learned all about the properties of fractional expressions. B over A is equal to B times M over A times M. B over A is also equal to B divided by M over A divided by M, where M is not equal to 0. Here's its application. The properties of fractional expressions can be used when simplifying fractional expressions and when we are performing operations with fractional expressions, which we will be getting to in our next video. So if you would like to stay notified for that, be sure to click the notification bell as well as the subscribe button. Anyways, this is a great time to pause the video and take some notes. Alright, here is our lesson summary. The two skills we learned today is to understand and master the basic properties of fractional expressions, as well as use the basic properties of fractional expressions to reduce and generalize fractional expressions. Thank you so much for watching through Inquisitive Kids, and I'll see you next time.